Dear students, greetings of the day. Today we will discuss about the types of intersections. Based on the number of addresses, we can classify the intersection into 4 types. They are 0 address intersections, 1 address intersections, 2 address intersections, and 3 address intersections. We will take one common example of x equal to a plus b star c plus d to showcase the demo of all the 4 types of intersections. First is the 0 address intersections. Here we do not specify any operands or addresses. Normally, stack-based computers, the 0 address intersections are used. Before evaluating these 0 address intersections, we have to convert the available infix notation, that is x equal to a plus b star c plus d, into postfix notation, that is x equal to ab plus cd plus star, because in stack-based computers, we evaluate the expression in from the postfix notation, and TOP means top of the stack, and M of x is memory at location x. We will see the example, then you can understand better. First, we have to use the push A. Push A is nothing but the push command stores the operand onto the top of the stack. Push A means you will store the operand A onto the top of the stack. Similarly, push B will store the operand B onto the top of the stack. Then add the third command, add. It will add top of the 2 elements A plus B and store the results again on the top of the stack. This is an example of the 0 address instruction. Here we do not specify any addresses. We simply use the command add alone, which will add top of the 2 elements A and B. Similarly, we can proceed. Push C, store the content of C onto the top of the stack. Push D, store the content of D on the top of the stack. And again use the add command that will add C plus B, C plus D, and store the result on the top of the stack. Then we have to use the multiply command. Again, this is also an example of 0 address instruction. Here already available results, that is A plus B multiplied with C plus D. The final result will be again stored on the top of the stack. Finally, we have to use the pop X. Pop command is nothing but it will retrieve the content from the stack and store it onto the memory at location X. That is memory at location X. Top of the stack value is transferred at the location X of the memory. So this 8 lines execute the given expression x equal to a plus b star c plus d by using 0 address instructions. Similarly, we will see 1 address instruction. Here we will specify only 1 address in the instruction. The another operand is available implicitly in the accumulator, that is AC. Here AC is nothing but accumulator. Again, we will take the same example, x equal to a plus b star c plus d. The format of this instruction is opcode. Opcode is nothing but operational code followed by the operand or address of the operand. Then finally, what is the meaning? The mode is nothing but here is nothing but what is the operation to be performed. So load A means we will load the retrieve the contents from the memory location A into the accumulator register AC. We'll transfer the memory location A value into the accumulator register AC. Then add B. Here already one operand is available in AC. So AC equal to AC plus memory at address location B content. The second operand is available at address location B. That will be added with the accumulate register. And the result is stored again in the AC accumulate register. We'll store this into the temporary location T. The T is nothing but temporary location. Store the AC result into memory at location T. Again, repeat the operation. Load C, load the content onto AC, add D, add the value of D onto the AC and store the results in AC, multiply T. Already M of T contains A plus B. Now AC contains C plus D. These two are multiplied. We will store the results again onto the AC. Finally, we transfer the content of AC at the location of X in memory. So these 7 lines program again is the example of evaluating the expression X equal to A plus B star C plus D by using one address insertion. Then next one is called two address insertion. Here the two operands are specified in the each and every insertion. The general format is opcode, designation address, source address, finally the mode. Here R1, R2 are registers. Again M stands for the memory location. Here we will transfer the memory at location A, the data available in memory at location A. We transfer that into register R1. Similarly, we will add the then move command transfers the content of M of A into R1. Then we will use the add command that will add the next operand available in at location B with R1. R1 contains the value of A that is again stored in the register R1. Now we will use the move command R2 comma C. So memory at content of C at address location C it transferred into R2. Add R1 comma D. So M of D is added with R2 and the result is stored in R2. Multiply R1 comma R2. Both are multiplied and again results are stored in the R1. Finally move X comma R1. The content of R1 is transferred to the memory at location X. So these 6-line programs give the demo about the how we can evaluate X equal to A plus B multiplied with the C plus D with the help of two address insertion. Then the last category is the three address instructions. Here we have to specify 3 operands or addresses, which may be either memory location or registers. The general format is opcode, designation address, source address 1, source address 2, then mode. We will use the command add R1 comma A comma B. So memory at location A and B is added and store the results in the register R1. Similarly, add R1 comma C comma D. The memory location C value and D value is added and store the results in the register R2. Finally, we'll use the multiply X comma R1 comma R2. Multiply the R1 R2 register values and store the results in the memory at location X. Here we are having only the 3-line instructions. So if the addresses increases, the number of instruction decreased. You start with the 0 address instruction, it contains 8 lines, and in the 1 address it contains 7 lines, and 2 address it contains 6 lines. Here we are having only 3 lines. So by the way, we have to reduce the number of lines if we increase the addresses of the instruction. Even though if you reduce the number of lines, the execution time of the entire program is same, because the number of cycles to execute each and every micro operation is same for all the instructions. So we can reduce the number of lines, but execution time is same in all the cases. I hope you understand the types of instruction. Thank you.